Welcome everyone to this meeting of the virtual CICS user group. I'm Trevor Eddles. I'm CEO of iTech Ed Limited. We're a mainframe consultancy, analysis and technical authoring organisation. We're responsible for the content on the virtual CICS website, and we produce a newsletter. I'm very pleased to announce that we now have a new sponsor, Hostbridge Technology. Thank you to them. And we have a new website at virtualcics.hostbridge.com. Let me apologise for the late change in the meeting URL. As I said in the newsletter, Hostbridge changed WebEx provider, and the new one promised that the changes would all be seamless, which it wasn't. So again, I apologise to the people who had already registered at the original URL. And you may have noticed that we're actually using WebEx meetings today rather than the usual WebEx events. So this is for one meeting only. Anyway, let's start by running through the agenda for this meeting. As usual, most of the meeting will be taken up with the presentation. And today our guest presenter is Saurette, Principal with MainTegrity Inc. And his presentation is called Providing System Integrity for Multiple LPARs with Improved GDPR and PCI DSS Compliance. And a copy of the slides from this presentation will be on the website later today. And there'll also be a recording of this meeting. And on the website, there are also recordings of earlier meetings. And that's all on the resources page, so you can access that at virtualcics.hostbridge.com/resources.htm. Following Al's presentation and any questions you have for him, we'll move on to the latest CICS news and the latest CICS related articles. Feedback request is there to remind me to ask you for your feedback about this virtual meeting. And then I'll give you the dates and times for the next couple of virtual meetings. So that's the plan for the meeting. I'm anticipating that it's going to last for just over an hour. Anyway, as I just said, today's presentation is from Saurette. Al is a principal at MainTegrity Inc. and is dedicated to improving security on mainframes and other platforms. For over 35 years, he's delivered innovative solutions to enterprise IT problem areas. With a strong operations background, he's a regular speaker at international security conferences, and he's authored many IT industry thought leadership papers. And he also tells me that MainTegrity is a member of the PCI Security Systems Council and works with clients organising to improve both application and system integrity, focusing on eliminating internal threats. So let me now swap over to make Al a presenter. Right, you should be presenter now, Al.
Okay, thanks, Trevor. And welcome aboard to everybody that's joining me today for sure. So let's see if I can find a session to present here.
Yeah, little buttons at the bottom, yeah.
Now, can you see that one? Oh, you've got to, didn't really see. It says you're still a host.
Oops, hang on. You're...
here we go. Let's see if I can find the right thing to present. Can you see that now, Trevor?
Yeah, that's it.
Perfect. Okay, and I shall start over here. So, I have the dubious honor of presenting from the IBM Share Conference at Fort Worth right now. So I'm attending the conference. I'm going to do a couple sessions tomorrow for the conference attendees, but you get an advanced look today because you're part of the virtual CICS group. So hopefully we'll have a few laughs as we go through here. I hope that I can present some interesting material, and I hope that it'll change perhaps some of the perceptions around the mainframe. I won't spend long on the agenda because, you know, we're basically going to go through what we do and what we bring to the mainframe marketplace. And I think it is verging on revolutionary, because I've been trying for my 40 years in the business to convince IBM that there is a difference between a technology, which is not a product, and a product, which is not a solution, until such time as it's implemented by real people. In our environment, we try to help with that process. And at the end of this, I'd appreciate it if you look at it and you say, yeah, the guys are doing what needs to be done here, or you know, it's just another product and I'll maybe look at it someday. With that, I will say all of us in MainTegrity are career systems programming folks with a big, strong area of enterprise operations management. All of the principals have been involved in launching enterprise software products since the early 90s. Lots of the companies that you do business with would use our products in a variety of ways today, or products that we had built. Beta, IBM, New Era, CompuWare all use substantially the products that we built for them and rolled out to their customer base. So, been around for a while. Even the concept of FIM Plus has been around for quite a while. We started on it because I was involved with SCM, particularly ISPW at the time, and we could see a need in the rollout of mainframe applications for a verification tool, so that we could verify during the implementation window, during the change window, whether the deployment was correct and everything was coming up as defined. And so we worked on that problem for a while, and then we felt that it played into a greater solution for security risks. So hopefully we'll have a little chance to talk that over this morning. In the long run, we had to build a company to build a product because there was no FIM solution, which is the underlying technology, in the mainframe arena. And then we set out to build a rock solid product in the system integrity space that not only assures security and compliance, but actually saves time and effort for systems programmers, as well as people that have to do audits and compliance and that sort of stuff. So January 2018, the new PCI DSS 3.2.1 standard came into force. And it required FIM processing on all platforms that handle credit card information. So we thought that would mean everybody would need our product immediately in the mainframe space. However, it takes a long time for these standards to be adopted and a longer time for solutions to be put in place. So we are really moving in that direction now, but the industry as a whole has not reacted quickly to the requirement. We'll talk a little bit about what we're doing about that, and that's specifically one of the reasons that I'm at the IBM Share Conference. But in the long run, what would you think about a group of old systems programmers, and I do mean old, that have a startup in 2018? That's because we thought the marketplace needed more help. So if I look at this from a customer standpoint, which I was for many years, one of the challenges we always had was to keep everything synchronized across multiple LPARs. And frankly, when I was with CompuWare for a little while after we sold ISPW to them, I went and saw some of the biggest customers in the world. And many of them were trying to manage 40 and 50 LPARs and perhaps geographical locations that are 12 hours apart, or 4 that are 6 hours apart, or a variety of other things. So we really thought that that was a problem that needed to be resolved. In addition, the whole notion of ensuring the integrity and making certain that what is in use, and whether it's executables or configuration parameters or whatever the case may be, what's in use today is what's supposed to be there, and that nobody's come in and tampered with it. So that brought us into the area of specifically insider threats, which is what we focus on. So MainTegrity doesn't really do anything. FIM Plus is a product that runs inside the wall. So we don't do anything about making the walls better or monitoring RACF or those kinds of things. We use a different information base to try to verify all the event records that you're probably already generating in your environment. That played into the audit and certification process in a really big way. I believe that we will be able to say quite effectively that we're the only product that can work right from the SMP install level, right through application and configuration delivery, and ensure that what you have running in your environment is correct. We think in the process we can save time and effort, and that comes from the fact that we auto-discover nearly everything, and that results in our zero admin initiative. Because if we can auto-discover, well, why don't we just go out and reflect system changes on a regular basis, and then we don't have to do a whole bunch of administration work, which I used to have to do when I was a system programmer, and frankly, in this day and age, you can move on to higher value activities. We also thought that in the process, we could modernize the mainframe and help bridge the knowledge gap to a new generation. And that talks to GUIs, and it talks to information presentation and being able to get all the relevant information in one place. That, we thought, resulted in making both the existing staff and new staff more efficient in their jobs. And that comes back to what we really want is a net reduction in the overhead time spent to improve internal security and compliance. We'd like to make that job go away. At the end of the presentation, you'll probably be able to tell me whether we got close or not. This is my favorite slide because I call it the insecurity slide, which is everybody thinks the mainframe is secure. And by golly, after 35 years of RACF and ACF2, we've secured the perimeter just about as well as you possibly can. However, systems keep getting broken into. And in our particular case, we look at the Ponemon report from last year. Detection itself took 206 days. 206 days. Well, that's more than half a year. How is that possible? Well, if you're watching your event records, it's probably not possible that you miss it for that long, unless, of course, your event records aren't telling you everything that's going on. But it takes a further, according to this report, 73 days. And you can get it right off the IBM site. And here's what it's called, the Ponemon report. Malicious attacks. These are only looking at places where there was a breach of, I believe, 100 records or more, but some of them are in the millions of records. And the root cause, in many cases, they say is malicious attack. But it's also human errors, which is I'm making some sort of change and I make a mistake, and all of a sudden I expose some records, or I create a security opening that shouldn't be there. Another element that they talk about is system glitches, which is basically anything that they couldn't trace back to a human being doing. So why do we think that matters? 7.7 trillion credit card transactions, 29 billion ATM transactions, still go through the mainframe. So it's a big target. Okay. Why 206 days? Well, chances are you don't ever catch the error. Probably card company or credit card supplier phones you up if you're a bank and says, "Can I talk to the chief risk manager?" And they say, "We have a pattern of fraud here that appears to reveal a breach of credit card information from your site." So what happens? How does that happen? Well, frankly, stolen credentials. It's really hard when you have legitimate credentials accessing files to what they have access to.
You're breaking up a lot. Is there
some
somewhere you can get closer to your mic?
I can, sure. Is that any better? Is that any better, Trevor? Hello?
That's better. Yes.
Am I still here? Okay.
I'm listening to the network.
All right. So I mean, a lot of things can bypass the perimeter, and we'll see a little bit about that. So we focus on what's happening inside, bit by bit comparison to make sure it's 100% correct or not. We report all the altered components, not just suspicious events. And we report those errors until such time as they are either accepted because they're actually correct or they're fixed. So it's really hard to overlook. And furthermore, we can go back in time and find errors that have been there for a long time. What is FIM? FIM is File Integrity Monitor. It's this simple. You take a snapshot, hashing codes. We use the crypto hashing that's available on just about every mainframe these days. We take a snapshot of your files, we create a hashing code, we save that hashing code away in the encrypted vault that we have. Later on, we take another snapshot, we call it a scan, and we compare the two sets of keys. If the two sets of keys are the same, then we say everything's fine. If they aren't the same, then we kind of hold our hand up and report an alert. Okay, so what do we look after? It can be executables, it can be JCL, it can be configuration parameters, it can be encrypted files, it can be USS files, it can be log files that are created and stored. Basically, anything that is supposed to be static on your system is what we look at. And that protects systems. It protects the applications. It can protect key subsystems like CICS or IMS or TCP/IP. And it is very high performance. Because we offload almost all of the arithmetic processing to the crypto cards, there's negligible CPU during the scanning phase, and the only thing we have to deal with is a few alerts from time to time. But the second that we find a problem, we send an email and a text alert directly to whoever's defined as the admin group. But we also integrate with the central consoles that you might run in the environment. So the popular SIEM products that capture all of the security information, we log our information there as well. So we do an active comparison, and that meets the test of what is required for audit and meets the test of what is required for compliance in many cases. And we'll see that in a second. So let's discuss for a minute what an insider is. Well, it's anybody that has access to your machine. So surely we have very strong walls. And it doesn't much matter what environment you're working in. You probably have firewalls, and you probably have very well entrenched access control from RACF, TSS, or ACF2. But since the Middle Ages or so, walls keep the bad guys out and let the good guys in. However, in the last while, the bad guys have gotten a little smarter. Now they steal credentials. So they actually get through that level of control by using credentials that are legitimate and look perfectly fine and have access to a subset of files. And they may use that opening to get access to other files, or to get access to supervisor C, or to get access to your APF library. There's another class of insider, which is a trusted employee who, by virtue of some misfortune, financial problems, marital problems, health problems, addiction problems, this employee goes bad. Now, they're actually much more dangerous than external folks because they know where the points of sensitivity are, and they know where the financial information that is key to the enterprise is located. Then there's another group of insiders, and they're well-meaning staff, but they make mistakes. One of the reasons why I'm not a systems programmer anymore is I was a little mistake prone. So after having overwritten the system pack once in the very early years of my career, I became a much more careful person, but not careful enough. So I would have loved to have a verification tool that told me before I got myself into any real trouble, was I pointing at the right system? Had I made the changes to the right place? Had I actually made the changes correctly? Did the changes that I tried and tested dutifully on the test system, were they the same as the changes that I was now trying to put into production? All those kinds of things. But as you roll them out across multiple LPARs, you have to look for the same sort of things. Did I get all of the information in the next LPAR there at the right time with the right content? And were there any exceptions? So when I go from one LPAR to another, the identifier, whether I'm on CIS-A or CIS-B, is certainly going to be different. So there are allowable exceptions that need to change as you go across. And any good program would take that into consideration as you move on. Traditional monitoring has always been manual, and because of that, it just doesn't get done. You're busy. Everybody's busy. It doesn't get done. So it also requires a lot of ZOS skills. So this is what we're really trying to deal with, is insiders. The other problem that isn't historical in nature, but is very timely now, is that newer people are coming in to support mainframes that don't necessarily have 40 years of experience. So it takes in-depth, to develop in-depth knowledge, as we know, takes years. But mainframes aren't more secure than other platforms. They're just not really well understood by a lot of hackers. However, that is changing in some of the recent news, kind of in the Chinese hacking and North Korean hacking. I think a lot of that affects mainframes in exactly the same way as it could affect other platforms. So what do we try to do? Give control and view of all the information required via 3270, GUI, or in your SIEM, however you want to consume it, and however the people working in your environment want to consume it. So what we also want to do is lead people through the forensics process. If we find an alert, first thing we want to do is verify whether it's a false alarm or it's a real problem. If it's a real problem, then I want to get into the process of solving that problem right away. But if it's a false alarm, I just want to click, no, it's a false alarm, and get back to, my real job today. Following on that, if it's a real problem, you want to know who, what, when, where, and why. And you need that data immediately, because that phone is going to ring. Somebody is going to ask you a question you don't have an answer to. And if it is at the wrong time, you may not even see the question coming at you. So we want to make sure that we're a fail-safe in that environment, and the admin group always has the edge in terms of time on what's happening. In addition to that, because we can look at every component, we can tell you which ones are affected. Half the time when there's a breach, you spend weeks just trying to rationalize and understand what all the affected components were. We know that before you get started at the get-go. And the zero admin initiative is also really important because we don't want you to have to spend the rest of your life updating information in FIM Plus. We'd really like you to be earning your living as a system programming, doing a lot more valuable stuff. So we always say you should know what's going on before the phone. How does this work? Okay, so turns out that we do an initial scan. We get that initial picture of the trusted version of everything. Then we can do multiple scans at points in time, whichever you think is important, because it's not very CPU intensive. You can do it several times a day. You might do it once a day. You might do it once a week, whatever you like. But our expectation is that you get the trusted version in the vault. You do a scan. There's another point in time where we know everything was correct. I do another scan. Oh, well, everything's still correct. Well, maybe that's Friday. Now, turns out, maybe I do a scan on the weekend. And on Sunday, there's something wrong. Holy crow. Okay, well, what do I have to do? I have to raise an alert. Well, everybody can do that. So we raise 2 alerts, actually. It can go out by email or it can go out by text directly to the admin team. It can also be sent to your SIEM platform and then use the internal escalation procedures that you might have in those products. But when I get that email, if I simply click on the email, it brings up the FIM GUI. And the first thing that the FIM GUI is going to do for you is it's going to say, was it approved? Well, how the heck would I know if it was approved or not? Well, the obvious thing is go out to the ServiceNow instance that you're probably running in the cloud somewhere, or maybe Remedy that you might be running on site or whatever. Go out there and verify that this change was approved or not. The next thing is I need to know what happened, what's affected. So we know the business systems that the components belong to. We also know all of the components that were affected. After that, we need to know the attack interval. Well, remember when I told you we wrote these success records over here? We know everything was okay on Friday because that was our last test. But by Sunday, something had changed and now we had a problem. So we know what that attack interval was. Once you know what the attack interval was, well, then you can just simply go out to the SMF data sets that are there. And we can pull out all the detailed information. That's exactly what we do. Once we've seen who did it and the exact time that it was done at, you might say, well, how about we look at the 2 components that are in error or compromised side by side. So we take what we call our baseline copy, which we built in the first step, our trusted copy, and we kind of go, show me the current copy side by side. Well, this works perfectly fine if that's something like a configuration file that would be easy to interpret by a human being. And it could be that the change is simply an extra space or it's a comment line that got added and it's perfectly fine, in which case you can go ahead and suppress the alert. But it might be a real problem, in which case we're going to invoke advanced processing. So what are advanced forensics all about? Well, first thing, you got to detect. So we went through our detection process, and we can detect things that are wrong versions. because the vault will hold multiple versions of anything. It will detect forgotten changes, which you will never detect with an access control mechanism. We can detect backouts that were incomplete. A lot of things that that can be resolved there, or we can detect a bad deployment, of course, which some deployments have a letter missing too. Anyway, the next step is we can eliminate false alarms, and I think by going through that whole process, you can kind of see we can determine what's a big problem and what is a small problem, and what is no problem. We log the success and failure. We go through and we say, was it authorized? All of this is done by the system for the user. So imagine how long that takes. Seconds. One click compared to the baseline. So let's see how that exactly works, because we're just talking about a limited number of clicks here. Okay, remember we sent a text email alert. I simply click on that alert, up jumps the GUI, and we see, oh, here's the component that's mismatched. Okay, when an alert is received, one click. When we open that up, I also know the time when that module was correct, the time when it was found to be incorrect. That means when I go to SMF to get all the records, all I have to do is look for the records during the interval. That means instead of going back to the beginning of time and looking at thousands of records, I only have to look at 3 or 4 or 5. In this example case, we're looking at TCP/IP. The second click actually goes out and fetches the ServiceNow information. So we can use ServiceNow in 2 ways. We can use it as an information, ServiceNow and Remedy. We can use it as an information base, which is, was there a change for this component planned at this time? And we can look at the configuration information inside ServiceNow and Remedy to drive that transaction. If there is an approved change, then we can say, well, why was that change put in? And does the component that's affected look like it really should belong to that change or not? But the other option is, if I'm the change manager and the deployment window is over and I want to find out if the change has been implemented and implemented correctly, I can drive the system from the other end, from the ServiceNow end or Remedy end, and say, please run a scan and tell me that the change that was supposed to go in 2 hours ago was completed correctly. Ooh. Oh, where did I go now? Okay, let's go here. Okay, so that gets me to defining my problem. Click 3 says, I might want to invoke that in-stream compare. And in our particular case, we kind of go, oh, the port definition got changed from New York to Russia. Is that a problem? Well, it might be. And then click 4. The logical next step is, if you know when it was trusted and we have proved that it's a problem and you know all the components that have to be restored, why wouldn't you just help restore them? So that's what we call the restore system. And it'll build the JCL for you, stage it into an environment. Once you've proofed it and said, yeah, I like the way this is, we can recover that for you by just running those jobs. And then the last step is we would recommend you run another scan and make sure everything is back to this trusted component. But that's all just a few clicks. That's the power of automation. So suddenly, when you have a problem, in the classic response, I am left with tons of questions. Is it a false alarm? When the heck did the problem start? Who did it? In the FIM plus access data, because we bring both together and use them intelligently. So this is not artificial intelligence. This is natural intelligence that we use to go through this process because we've been through it so many times. Is the alarm verified? Well, know why this was done in the first place. Know the scope. All of those changes are going to come up. And then, once I get into corrective action, help me take that corrective action. That's where the recovery assistant comes in. So we think that you ought to be able to recover in minutes, whereas it is very likely to take weeks and be very error prone trying to do this manually. And try to imagine it's not the world's most experienced mainframe systems programmer trying to do this. Maybe you outsource some of that stuff. Maybe those guys know what they need to do and maybe they don't. And when I think about this in the hands of the younger generation, in the hands of people that are offshore, I want to make sure that they've got as much automation and as much support as is possible. So how does that fit in an overall security context? We think a really good way to look at this is the way the NIST cybersecurity framework is put together. As I said, really, FIM Plus doesn't do a whole lot of protection. It helps you certainly with governance, but it really helps you in the detection phase. It really helps you in the response phase. For instance, adding a new component that we call content comparison. It helps you a lot in the recovery phase because we add a few new components like select the restore files and verify the restore. This is important stuff. And it happens only when you're in a really tight place in the corner and everybody is screaming. Beyond that, there's a thing called PCI compliance. So for everybody that handles credit card information, somebody in your organization signs a form that looks an awful lot like this. And your CIO, your CFO, or your CEO is saying all of the PCI specific controls are in place and being followed. That's the attestation. Most places don't realize that FIM is a required part of, in particular, 11.5 and 10.5. But it's key to being able to do 6.4 and the whole of Section 12 in the PCI Compliance Guide. And that's the same in 3.2.1, which is now, and version 4, which will probably come out at the end of 2021. So what do? We harden the security. That always improves compliance. But then we actually produce better reporting and on-demand audit processes so that we can prove categorically that you're fully in compliance of those controls. And that saves you a ton of time. So when the auditor comes in and he goes, can you just prove to me that what's on the test system and came out of QA is what's running in production? You can push a button and about 30 seconds later you can have a report, and you can hand the report to the auditor, and you can get the auditor out of your office. And chances are he'll be amazed, and because it's probably an external auditor, your company will save lots of money. Not only that, you can go to the CIO and say, you can sign off on this because you know you comply. So with that, I'm going to sum up a little bit, and then I'm going to turn things over if there's any questions that come in from the field. But what does this allow us to do? Verify systems. Manage multiple versions of application systems, banking systems, ZOS systems, CICS systems, whatever you want us to look at. And we can even incorporate specific deviations that you've approved. We can detect unauthorized changes and errors. We can identify when your QA system has changes from your production system because it's drifted away. Often enough, emergency changes, you change something at 2 o'clock in the morning, you come back in the next day, you got a bunch of different problems. You forget to put that emergency change in. That's what we call code drift across LPARs. So one of the things we can do with the product is we can simply compare LPAR to LPAR and see if they're all the same with specific deviations built in. So you don't get a bunch of false alarms. We talked about it being retroactive. We didn't talk about the integration with the application side of the house being Endeavor, Changeman, and ISPW, but we can use some of the configuration information from those SEM tools to understand the makeup of application systems in the self-discovery phase. So not only do we discover system components, not only do we discover your APF libraries, all of them that are in use, in addition to the ones that might just be defined. So if an APF library was added by an operator, we would know that. We can we can verify the CICS libraries. We can verify the transactions, those kinds of things that are static. Anything like that, you will know for sure is correct. And frankly, you can prove it to anybody that comes through the door. So our newest feature is SMPE tracking. And in that feature, which I want to be clear is not available quite yet, it will read the SMPE database and look for any alterations, adds, deletes that are in your production environments, or for that matter, even your test environments, if that's what you want to audit. And then complete forensic info gathering and presentation. So the auto discovery is pretty cool. We say that you can install FAM Plus in an hour and get usable and useful information that you may not know after 40 years in the business, may not know from your own system. But more reasonably, it probably takes you kind of a day to get to that point. But we're not talking about days of implementation or changes to application components or subsystems or transactions or anything else. It's all discovered for you. We detect changes that bypass existing tools because these people are already inside. Respond to incidents faster. If I haven't convinced you of that by now, I'm not gonna. And at the end of it all, we kind of go, you can run this 100% on the mainframe, or you can put the GUI on and all you need is a web server environment, no big deal. Or you can feed the enterprise security console and run everything from there. But we really say you should think about this type of technology and start preventing problems today before they bite. And as a wrap up, I just say, it's actually such an easy product to trial that maybe you should just do that. You don't have to take my word for anything. You can try it for yourself. It's free and it's quick. And frankly, at the end of the day, I was on the other end of this statement before. If a problem occurs, who gets hung out? I always tried to make sure it wasn't me, because it wasn't very comfortable when it was. So with that, I'll turn things back over to Trevor. And if you have any questions, I'm quite happy to answer them. But, I see mainframes as a very viable platform going forward for many years. And that is certainly the key flavor coming out of Share this week. I mean, for 30 years, I've been saying the mainframe is not dead. And for 30 years, people have been trying to prove me wrong. And I think they're finally coming around to my point of view. So I'd say we better take a full advantage of that and defend them properly, because one of the big reasons why people still use mainframes is because of rock solid security and we're just trying to make it better. Anyway, with that, I turn things back over to Trevor.
Okay, brilliant. Thank you very much. Just hang on for a second then and see if anyone's got any questions. There's a chat box that people can use. They can put questions there, and I'll read them out. So we'll just give everyone a sec. So you were actually speaking this week, Al?
Yes, I got 2 sessions tomorrow. So this one came up just about the right time.
In like the security stream, or are you in the kick stream as well, or where are you speaking?
I'm not. Tomorrow at 3, I'm in the security stream, but this product also fits very well in the DevOps area. So because we use REST APIs and we really support other platforms very well, a lot of the tools that are used to build even mainframe systems these days, a lot of those tools are resident on other platforms, Windows or Linux or Unix or in the cloud. Our product fits because it uses REST APIs to communicate to everything else. It communicates in a consistent web service manner, which means these days the guys in DevOps want to see me as much. Well, they don't want to see me; they just want to see the product. But anyway, we have a community of interest in that as well.
Okay, brilliant. Have you got a slide with your email address on it? Because if you put that up and anyone thinks of a question later, they can just jot down your email address and get straight to you.
Gee whiz. That's a terrible thing. I didn't do that, but why don't I just put that on the screen? Oh, yeah, it's on slide 1. Let's go back there. That's a good place. Well, there I am in small print at the bottom. You can, I'm pretty easy to find, and I know that you've got Trevor's email address, so worst comes to worst, you can always phone Trevor and he can find me.
Yeah. I mean, anyone who emails me, I'll at MainTegrity.com. He'll get back to you, I'm sure, as soon as he gets back from ship. All right. Well, I can't see any questions coming. Let me thank you very much, Al, for the presentation. Very interesting. Gosh, so many days to spot that you've been hacked. That's frightening.
Well, thanks for having me aboard, Trevor. It's always a pleasure.
Yeah, can you see that we're giving you a virtual round of applause then from our virtual viewers? Share. Connected. Yeah, great. It's a bit slow. Yeah, we haven't got any news, so I'll gloss over that quite quickly. Articles, there are 2. We've got CICS and Kafka integration. That's by William Me on the CICS Dev Center, put up on the 6th of January. Maven plugin 1. Dave Nice. That's also on CICS Dev Center. Was back in feedback requests. As always, can I ask feedback about this meeting? You can comment on anything good or anything that you think we can improve on for next time. You can email your comments to me. The address is on screen at the moment, or you can use the Contact Us webpage. So looking forward then, as you can see, on the 12th of May, we hope to have IBM Stuart Francis, and we hope he'll be with us discussing CICS bundles and Maven. If you don't know, is a automation tool used primarily for Java projects. Then on the 7th of July, we're hoping the always popular Colin Pearce will be with us. We haven't agreed a topic for that one yet. A reminder that you can keep up to date with what's happening in the world of CICS and on the virtual CICS user group website. Virtual CICS group on LinkedIn. The URLs are all on the page of our website, which, as I said, is virtualcics.hostbridge.com. And of course, being social media, we like likes. So if you're on Facebook, if you can like us up. And if you tweet or Instagram or any of those things, then the hashtag is #virtualCICS. Okay, well, that's all for this meeting of the virtual group. Can I thank you all for attending, sponsoring our user group, and I'd particularly like to thank Al Saurette for his presentation. So that's it. Thank you all very much for joining, and I'll see you next time.